Welcome to aminacademy.com. In physics, let us discuss about Kepler's law of planetary motion, some solving problem. Look at this example. The planet Mars has two moons, Phobos and Deimos. The Phobos has period 7 hours 39 minutes and an orbital radius of 9.4 into 10 raised to 3 kilometer. Calculate the mass of the Mars. Assume that Earth and Mars move in circular orbits around the Sun, with the Martian orbit being 1.52 times the orbital radius of the Earth. What is the length of Martian years in days? First, we have to calculate mass of the Mars by using law of Kepler laws of planetary motion. Look at here first. You know the formula, that is T square is equal 4 pi squared over gm r cube by using Kepler's law. From this, we have to get it here. Here is 4 pi squared by cross multiplying r cube by gt squared. Now we'll apply the values. Equal 4 into 3.14 the square into our radius is 9.4 into 10 raised to 3 the cube radius, that is over g is a universal constant 6 into 10 raised to minus 11 into t, time conversion of this the time 7 hours 39 minutes in seconds will do. We have to convert 7 hours 39 minutes is in terms of seconds is 459 into 60 the square, that is t square. So by using this expression, by using calculator, we are getting equal 6.48 into 10 power 23 kg. We got, calculate the mass of the Mars is 6.48 into 10 power 23 kg. Next part of the question, assume that Earth and Mars move in a circular orbit around the Sun, with the Martian orbit being 1.52 times the orbital radius of the Earth. What is the length of Martian years in days? Now, second part, we know that for Kepler's third law, we have Tm square over T earth, Te square is equal radius of mass cube over radius of earth cube. By using this relation, we are having Tm is Tm equal Rm cube into T square over Re cube, all are power half. Then we are getting this by using the values. Already we have which is equal 1.52 times 1.52, where Rm is the Mars sun distance and Re is the Earth sun distance. Therefore, Tm equal 1.52 power 3 by 2 into 365. By using the values here, and we get like this. Therefore, 685 days equal 684. Now, next question. It is given that G equal 9.81 meter per second and R equal gravitational radius is equal 6.37 into 10 power 6 meter. The distance to the moon R equal 3.84 into 10 raised to 8 meter, and the time period of the moon's revolution is 27.3 days. Obtain the mass of the earth in two different ways. Here, first mass of the earth m equal G Re square, radius of the earth square over capital G, which is equal 9.81 for G into radius is 6.37 into 10 power 6 the square, all divided by 6.67. G values is 10 power minus 11, which is equal, by using scientific calculator we can find, which is equal 5.97 into 10 power 24 kg. This mass of the earth. Here one way, this direct universal law, we are using this one. Next, by using Kepler's law, we know that the moon is a satellite of the earth. From the derivation of Kepler's third law, we can use T square. T square is equal 4 pi square R cube over G mass of the earth, which is equal, here is the values, 4, 3.14 square, radius is 3.3 3.84 into 10 power 24 whole cube. The radius of the earth here, this here not 24, this is 8. Then over G constant is 6.67 into 10 raised to minus 11 ME. Mass of the earth is from that we have to calculate mass of the earth. ME equal by cross multiplying 4 pi square or cube by gt square. That means here t square come here, g me go that side. Here we are applying the values, which is equal 4 into 3.14 the square into r is 3.84 into 10 power 3.14 into 10 power 8 the cube r cube over g is 6.67 into 10 raised to minus 11 t. Time we had to convert this 27 days is converted to second, 27.3 days. That is equal 27.3 days, 24 hours, 60 minutes, 60 second, the square. By calculating all these values by using calculator, we are getting ME equal mass of the earth is nearly about 6.02 into 10 power 24 kg. Look at here. Here we are getting mass of the earth is 5.97 into 10 raised to 24 kg. By using this method, we are getting 6.02 into 10 power 24. It is nearly equal. This is 5.97 and 6.02, which are nearly equal. So we got in both ways the mass of the earth. We have done. Please subscribe our YouTube channel.